All right, today we are diving into some really cool research. It's called Artificial Neural Networks Applied to Diagnose and Troubleshoot Refrigeration Systems. Now, I know that sounds like a mouthful, but trust me, this is about a technology that is quietly changing our world 1 degree at a time. So let me ask you a question. What do all these things have in common? Your food, your air conditioning, those giant data centers that power our digital lives? Yep, they all depend on refrigeration. It's pretty much the unsung hero of the modern world, right? Just humming away silently in the background. But there's a lot more going on than meets the eye. Because here's the thing. These incredibly powerful, yet basically invisible systems, they come with a massive hidden cost. I'm talking about enormous amounts of energy consumption, which, has a big impact on greenhouse gas emissions. And what happens when they fail? Well, it can be totally catastrophic. We're talking everything from spoiled food to critical data centers going completely dark. So, here's how we're going to break down this amazing research. First, we'll uncover the hidden cost of cold. Then we're going to see how we're teaching machines to listen, which is super cool. After that, a quick look at the 4 steps of cooling, and then we'll meet the AI diagnostician. And finally, we'll wrap it all up by looking at what a future with smarter systems could really mean. All right, let's get into it. First up, the hidden cost of cold. Let's really understand the challenge that we're up against here. Look, refrigeration is absolutely fundamental. We just can't live without it. But its massive energy appetite is a real problem for sustainability. And maybe even worse, these systems can just fail out of the blue, leading to super expensive downtime and repairs. So the key takeaway here is this. Making these systems more reliable and efficient isn't just a nice little upgrade. It's a critical challenge we absolutely have to solve. So that brings us to Section 2, teaching machines to listen. How on earth do you make a complex machine like a refrigeration system smarter? Well, you give it a new kind of technician, one that never gets tired, never takes a break, and never sleeps. And we do this using something called an artificial neural network, or an ANN for short. Just think of it like a digital brain. It's inspired by our own brains, really. See, just like we learn to recognize patterns from experience, an ANN can be trained on tons and tons of data from a cooling system. It learns what normal looks like, and more importantly, it learns to spot the signs of a problem. It's almost like a trainee doctor learning to diagnose an illness by studying thousands and thousands of patient charts. So how does it actually work? Well, it's a pretty straightforward 3-step process. First, it's all about the input data. The ANN is constantly gathering real-time info from sensors all over the machine. Pressure, temperature, you name it. Second, that digital brain gets to work. It analyzes all that data, looking for tiny patterns or anomalies that a person might completely miss. And third, when it spots something wrong, it gives an output, a clear, simple diagnosis that a human can actually understand and act on. Okay, now to really get what this AI is doing, we need to pop the hood for a second and look at the actual heartbeat of any refrigeration system. Let's talk about the 4 steps of cooling. Whoa, okay, I know this diagram looks pretty intense and technical, but don't worry about it. This whole complicated-looking thing really just boils down to 4 key steps that happen over and over and over again in a loop. It all starts with compression. A gas gets squeezed, which makes it really hot. Next is condensation. That hot gas cools down and turns back into a liquid. Then comes expansion. A little valve drops the pressure way down, and that makes the liquid intensely cold. And finally, evaporation. That super cold liquid absorbs heat from its surroundings, which creates the cold we want, and it turns back into a gas, ready to start the cycle all over again. That's it. That's the whole magic trick. All right, Section 4, the AI diagnostician. This is where we put it all together. We've got our 4-step cooling cycle, and we've got our AI brain. Let's see how we get from raw data to an actual diagnosis. So you can think of the AI as a digital detective. It is on the case 24/7, constantly watching those 4 key steps through all the sensors placed around the system. It's checking the pressure after the compressor, the temperature of the condenser, the flow rate, you get the idea. It is literally watching everything all at once. Now this is where it gets really amazing. This is how the AI translates machine language into plain English. It sees a certain combination of sensor data, let's say a big pressure drop between 2 points. And because of its training, it knows that means, hey, the filter is probably blocked or dirty. Or it detects a tiny change in refrigerant levels and flags a possible refrigerant leak. It's turning all that complex, raw data into simple, actionable intelligence. It's just brilliant. And that brings us to our final section, smarter systems, greener future. What's the real-world payoff for all this incredible technology? What does it all mean for us? Well, the impact is huge. By catching these problems super early, it drastically cuts down on energy use and maintenance costs. It minimizes that cripplingly expensive downtime we talked about, and it even improves safety. But the biggest deal here is that it lets us completely change our strategy. We can move away from being reactive, fixing things after they break, to being predictive. We can prevent failures before they even happen. That is a total game changer for your efficiency and sustainability.
The authors of the paper really said it best. Their whole goal was to advance the knowledge and understanding of how artificial neural networks can be used to improve the reliability, efficiency, and lifespan of cooling systems. And from everything we've seen, I'd say they are definitely succeeding.
So, what's the big idea here? At the end of the day, this technology is about so much more than just building a better air conditioner. It's a blueprint. It's a way to make all of our essential, complicated systems smarter, safer, and way more sustainable. And that leaves us with one pretty fascinating question. If we can give a refrigerator a brain, what should we teach next?